She places object P with its center on the meter rule at the 10.0 centimeter mark. The object covers the scale marking on the meter rule as shown in figure 1.2. See, we cannot see exactly where is 10 centimeter and how we are going to adjust it so that it will be on the 10 centimeter. It's a problem and we are facing it a lot of time. Explain briefly how to place object P as accurately as possible with its center at the 10.0 centimeter mark. You may add to figure 1.2 or draw another diagram to help you your explanation. How we are going to do this? First of all, we are going to bring the meter ruler and draw it like this. Here is the meter ruler. And then we are going to place the mass from the above like this. So we are going to have a side view. I'm going to add a mark on the mass exactly at the center. So mark, I'm going to place it here on the meter rule. And I'm going to add a mark on the 10 centimeter. This mark on the ruler exactly aligned with the 10 centimeter. Another mark on the meter rule at the 10.0 centimeter. I'm going to match the two marks so we know that it is exactly on the midpoint of the mass. Okay?
Okay.
It's enough. We have mark on the mass. Mass what? Mass P or Q? Mass P. The drawing is enough because it's one mark and another mark on the meter rule at 10 centimeter, and the two marks are matching. The student places object Q on the meter rule and adjusts its position until the meter rule is as close to balance as possible. It's very difficult to balance this, and I think I tried with you. I don't remember if I tried with you in the lab to balance the meter rule, and it was so difficult to balance it on such pivot. It was close to be balanced. Okay, she records the distance A, which is 40 centimeter. Distance A, 4 centimeter, of course. Here at the midpoint, which is 50 centimeter, and here we have 10 centimeter. So the difference between them will be 40 centimeter. So A is 4 centimeter. Okay. Between the center of the object P and the pivot. The center of object Q is at 71.2. So here we have the center is at 71.2 centimeter. The midpoint exactly for balancing it. Okay. Determine and record in the table 1.1 the distance between the center of object Q and the pivot. Show your working. Of course, we are going to find the difference between them. So 71.2 minus 50 will give us the distance P. The distance P between Q, the center of Q, and the pivot. What is the difference between them?
$21.2.
21.2.
2.
Are you sure? 71.2 minus 50. 21.2. Okay. Okay, Shabab, centimeters, of course. So we have 21.2, and I'm going to place it here, 21.2. She repeats the procedure with the object PE placed at 15 centimeter mark, 20 centimeter mark, 25 centimeter, and so on. All the values of A and B are shown in table 1.1. We have all the values of A and B. Plot graph of A in centimeter on the y-axis. So I'm going to place A centimeter on the y-axis. Again, it's P also per centimeter on the x-axis. One mark for this. You don't need to start your graph from the origin. It's okay. So here is the value 20, 25, 30, 35, 40. How many divisions? 1, 2, 3, 4, 5. 5. And how many divisions we have here? 1, 2, 3,
Five.
4, 5, and 6.
Five.
6. 6 divisions. 6 lines.
Ah,
Okay.
yeah. 6.
1, 2, 3, 5
Yeah.
divisions and 6 lines. We can start from 20. We can start from 20, 25, 30, 35, 40. Maximum 40. Okay. We can do it like
So
this.
we can start from 15, صح؟ إذا بدأت من 15 بعدين 20, 25, 30, 35, 40.
15. You want to start from 15, 20? Yes. 25, 30, 35, 40. And here I'm going to place A per centimeter. Okay. And what about the second? What are the values? We have 9, so we are going to consider it 10 and 20. 10 to 20 or more than 20. So we can start from 5, 10, 15, 20. But it will be very small. It will be compressed because it's two divisions. What do you think? Let's make it 4. Yes, يا حسين.
احنا عندنا هون كم lines 1 2 3. طيب ممكن نبدأ احنا من
4 8
5 ل 25. From 5 to 25 يعني 5 10 15 20 25.
Yes. If we did like this 5 10 15 20 we are 21. So here and the 9.7 here, it's still 2 divisions out of 5 divisions. So it will be compressed.
10 15.
If we the same, we have to decrease the
أيوة
4 8 12 and then 4 8 12 are going to 16 20 24. Yes, I think 4 is better.
Yes.
Because we are going to start from 9. So 9, it's about here. 9. And we have 21. So it will be like this. So it will be more than 50% or about 50% of the graph. So this is better. But we need to know how many divisions. So each division here with 0.04. 0.04. Each small divisions. It will be a little bit difficult, but it's okay. Let's plot the graph. 9.7 with 20. So 9.7. We have 8. 8 from 9.7, it will give us 1.7. 1.7 over 0.04 will give us how many small divisions we are going to count after 8. So I'm going to do it like this. 1.7. 1.7 divided 0.04. It will give us 1.7. 1.7 divided by 0.04 will give us.
Why 0.04? Mr. 0.4 مش 0.04.
0.4, yes, 0.4. 1.7 divided 0.4.
9.7.
Yeah, 1 second. It's 4 divisions, 4 and a quarter. Yeah, Hussein, we have 8, okay? We have 8. I'm going to count after 8. How many small divisions I'm going to move? 8 and from 8 to 9, it's 1.
Okay.
From 8 to 9.7, already counted for me. Till 8, it's counted. So I'm going to add after. So the 4 divisions, 4 and a quarter. So 1, 2, 3, 4. 4 and a quarter, yani I'm going to consider it 4. So here is the first dot. Okay? Got it?
7, 20. Yes.
What about the second? The second is 35. 25 with 12.8. We have 12.8 means 2 divisions.
0.3. Mr. 12.3.
12.3. Ya Allah, 12.3. Okay, so the difference is 0.3. 0.3 divided by 0.4 will give us 1 division.
1.
So it's 1 division between 25. 25 was 12.3. here is the second dot, and then 15.1. So it's like 15. 30 was 15. Where is 15? We don't have 15. We have 12. So it's 12 minus 15.1. It's like 3.1. 3.1 divided by 0.4. 3.1 divided 0.4 will give us 7.75. It's about 8 divisions.
Yes.
So after 12, we are going to move by 8 divisions at 30. So 1, 2, 3, 4, 5, 6, 7, 8. Yani it's not 8 exactly. Before 8 a little bit, we are going to put it like this. Here is the third point. And then 17.8. 17.8. It's like 1.8. The difference between 16 and 17.8, 1.8. 1.8 divided by 0.4. 1.8 divided 0.4 equals 4.5. So I'm going to move 4.5 at 35. 1, 2, 3, 4.5. So it's here. Okay. And then 21.2. We have 20. So 1.2 over 0.4. It's like 3 divisions. So at 43 division. 1, 2, 3. Exactly. Here is the dots from the graph. You got it, ya shabab?
Yes.
Alhamdulillah. And then we are going to bring the ruler. And then we are going to plot the straight line that passed through all of them. Seems like this. I'm going to make it thin and continuous line. Let's consider the best fit straight line passing through them.
مستر أنا رسمتها زي هيك بيبان هبعت لك صورة.
طيب. Where is Shanzeh? Shanzeh was here in the beginning. Because maybe she noticed that we are recording. She said no need for attending. I don't know. اوكي يا شباب.
أنا لسه بعت لك الصورة.
اوكي يا حسين. Why ignored the last one?
لأنه أنسر مش راضي تزبط معي. أخذت الأول 4.
يا حبيبي. It's the same like
أعيدها؟
mine. No need, but it's why it's like this? See, look at mine here. Look at this point and that one. See, one of them is above the line and the other below the line, and the 3 lines are aligned together. So my line is symmetry among all of them. Is passing 3 points, and the other 2 is in between. This is the best fit straight line. Well judged.
Okay.
Well judged. But you ignored one of them. You match it 4 and you ignored one of them. But it should be among them because the difference is not too big. The difference among the last 2 and the graph line is not too big. And if it is too big, we can ignore it. And if it is here, for example, the dot is here, I'll ignore it because it doesn't match with the others. But here, the difference a little bit, but it doesn't matter. Leave it like this, and we are going to find the gradient. Okay? We are going to find the gradient, and we are going to find the difference.
غيرتها عملت زي اللي انت عملت. ايوه.
Allah, it's now better. But another thing, the the cross sign for the dot is too big, too big. I need it to be small to the nearest small square, half of the small square, half of the small square. Check the small square, the smallest square. You have half. Check mine here. Within half of the small square, within half of the small square, within half of the small square, half here. Yours is like this. Correct?
Yes.
Yours is like this. When you put it in the normal size, it's like this. Check mine, a little bit smaller than yours. Determine the gradient. Determine the gradient G. Yes, go ahead.
مستر هو ليش ما اطلع الجريدينت من التيبل نفسه؟ يعني ليش ما اعمل مثلا 40 minus 30
لا impossible to do it from the gradient. Impossible, and it won't be accurate. He needs a clear triangular method. I told you several times this. We cannot use the data from the graph because actually, see, the data is not correct. And we have 2 points, it's not on the graph line. So we are going and we are finding the best among them. So it's like the graph will give us an average among them. So when I'm going to find the gradient, it will be more accurate by using the largest triangle that cover more than 50% of the graph line even. And I cannot do it like this with this. No, we need the largest triangle.
Okay.
So here is the largest triangle. I'm going to delete the other one. And I'm going to use this number and that one. And here. And here. Okay. So we are going to count. Here is 20. Okay. And here is, what is the second point here? We have 8 and 4 division. 4 is like 1.6. 1.6 with 8, 9.6. So here, 9.6. So the gradient will be the difference in y-axis. Here is 20. And here, each 2 divisions was 1. 36, 37, 38 and half. So 38.5 minus 20 over 20 minus 9.6. Check yours. Don't depend on my data. Yani through yours and check and give me the results. 38.5 minus 20 over 20 minus 9.6. Why it's negative? 20. It's 1.8. 1.8 without unit. Why? Because it's centimeter over centimeter. The gradient ranges from between 1.6 to 1.9. What is yours, يا حسين؟
ثواني بس
مروة. يا أوس, you are doing with us?
Mister, I'm doing
start my 1.85.
9.85.
1.9.
يعني 1.95 ولا 9 بس؟
لا
يا حسين.
لا 1.85 عملت لها راوند وصارت 9.
Okay, you are on the edge of the correct answer. Mine in the middle, smooth, away from the least value and the largest value. The least value is 1.6 and the largest is 1.9. Marwa, what was yours? The gradient?
75.
بالظبط.
1.75.
Yes.
اوكي يس يا حسين.
انا طلع معي 1.85 وسويت لها راوند عشان تصير 1.9.
اوكي no problem. تمام correct. The gradient G of the graph is equal to the ratio of the masses P and Q. Record the ratio R of the masses P and Q. Give your answer to the suitable number of significant figures for this experiment. 1.8 still. Two significant figures is okay.
مش فاهم.
He said the gradient of the graph is equal to the ratio of the masses P and Q. Record the ratio R. R is the ratio of the masses, which is G of P and Q. Give your answer to suitable number of significant figures for this experiment. The suitable number of significant figures would be two significant figures, so 1.8. So it is the same number.
شوي بس.
R equal G. The ratio is equal to the gradient.
هو 3 significant figure مثلا.
Yours is 3 significant figures. It's okay. Accepted.
طب شوي مستر مش فاهم يعني الريشيو هو الجريدينت.
Yes, he said like that.
Mr. why 2 marks?
2 marks
What?
because you are going to write R equal G.
طيب.
And he's already mentioned that. And it has no unit. Maybe 1 mark for the result and the other for the significant figures. Okay, Shabab? We are done with
Okay.
question number 1. Let's go to question number 2. A student investigates the resistances of combinations of resistors. The first circuit arrangement is shown in figure 2.1. RA and RP, two resistors connected in series. RA and RP. We have voltmeter across the two resistors, and we have a meter, we have switch, we have a power supply. Okay. The students measure the current and decides to use a lower current. He adds a variable resistor to the circuit to reduce the current. On figure 2.1, mark with an X a suitable position in the circuit for the variable resistor. Where we should place the variable resistor, ya shabab? Where should I place the X?
variable resistor.
Yes.
في الار.
Where? I'm going to put an X sign. Shall I put it here?
لا.
Correct. So where?
Before the RB. يعني before.
يعني in between them?
لا before to the right.
Here?
I think yes.
It's okay. Here or there. It's okay. Even here. These 3 positions are accepted. So I'm going to put an X sign to the place where we can place the variable resistor in order to control the current, to minimize the current to the lowest. Okay. Here, the students measure the current I1 in the circuit, record the current shown in figure 2.1. 2.2, in figure 2.2. Here is the current. Here 0.2 and here 0.4. The difference between them 0.2. How many divisions? 1, 2, 3, 4, 10. But each small division is 0.02. 0.02 times 2 will give us 0.04 plus 0.2, so it will be 0.24. So 0.24 amperes. He measured the potential difference V1 across the resistors R1 and RA and RP in series. Record the potential difference V1 shown in figure 2.3. So we have 2 and we have 3, and the difference between them is 1, and we have 5 division. 1 over 5 will give us 0.2, so it's 2.2. So it's 2.2 volts, and here 0.24 amperes. I was about to write the unit. I thought I forget to write the unit, but I found the units are written. calculate the resistance R1C. It doesn't ask you even to use the equation for finding the resistance R equal V over I, and it is given to you. So in paper 6, it is about the technique. It is not about the measurements. If you want to do the exam in the next class Sunday, I'm going to bring an exam paper exactly the same, paper 6. If you want to come to do it here in my house, you are welcome. Until the other,
Sure.
calculate the resistance R1 of the combination of, so R1 equals, what is V1? 2.2
2.2
over 0.24.
0.24 9.2
uh,
9.2 مثلا
9.2 ohms. Okay يا شباب, the students connects a resistors RC in parallel with the resistors RA and RP. Okay, in parallel with these two RC, he doesn't change the series combination of resistors RA and RP. He connected the voltmeter across the combination of the three resistors. Draw a circuit diagram showing the circuit described in D. So we have the two resistors. And the third, they are connected in parallel. Okay. We have the ammeter here, and shall we place the voltmeter, the variable resistor? Okay. And here is the voltmeter. Here is the circuit. Here is RA, here is RP, here is RC. The student connects a resistor RC in parallel with resistors RA and RP. It doesn't change the series combination of RA and RP. They are in series still. He connected the voltmeter across the combination of all the three resistors. Actually, is asking about this, only this combination. Got it? The students measure the current I2 in the circuit, 0.68. The current is increased. You can see 0.68, and it was 0.24, because by adding a resistor in parallel, the total resistance will be smaller than one before. You measure the potential difference V2 across the combination of the three resistors, 2.1, and the V2 is the same. Calculate the resistance R2 of the combination of resistors. Use the equation R2 equal V2 over V1. C includes the unit. V2 is 2.1 over volts over I2 is 0.68 amperes, and the resistance will be in ohms. You are going to substitute and find the result. 2.1 divided by 0.68. It will give us 3.1. 3.08 or 09, so it's like 3.1. 3.1 ohms. Okay, شباب?
Okay.
The student rearranges the resistor to set up the circuit shown in figure 2.4. Okay. He measures the I3 in the circuit. Here is I3. He measured the potential difference V3. Now he's connecting RP with RC in parallel with RA, and the total, the combination with A in series. And here is the voltmeter to measure the potential difference across them all. And we have the switch, and we have the ammeter, and we have everything. Okay. Is asking for calculating R3. Calculate R3 of the combination of resistors. Use the equation. Include the unit. Give your answer to a suitable number of significant figures for this experiment. Okay, R3 equal V3 is 0.29 over 2.1.
Mr.
Yes, 0.2.
2.1 over 0.29.
2 point,
Mr.
yes,
2.1.
2.1 over 0.29. 2.1. 2.1 over, yes, Marwa, how much?
7.24.
7.2.
7.2. 7.2, forget about the 4. You can write it in 3 significant figures,
Yeah.
it doesn't matter. But don't forget the unit, ohms. Okay? A student thinks the 3 resistors, RA, RP, and RC, have the same resistance within the limit of experimental accuracy. Suggest how the student could use the apparatus provided to test this idea. What do you think?
Measured resistance.
Voltmeter and ammeter for the resistors and calculate the resistance again.
We can use the ammeter and voltmeter and measure each resistor separately by using the voltmeter and ammeter and the same circuit, or each resistor separately, and they compare between their values.
But Mr. Ali using the same apparatus.
I'm going to use the same apparatus. Same apparatus means the same ammeter, same voltmeter, same power supply. I'm going to place each resistor